Amazon's The Boys, unquestionably my favourite TV show from last year. Actually, Mandalorian came out too. Arguably my favourite TV show from last year, has returned with a second season. So I asked you on my community feed which aspects from season 1 you'd want me to break down from a medical science point of view. So whoopsie doozy calls, let's get on with it.
Yeah. Don't you ever besmirch Billy Joe.
There is no better way to kick off this video than this scene here with Hughie and Robin, bringing a whole new meaning to the phrase holding hands. Robin completely explodes from the force of being run through by A-Train. I have no idea how to even describe this in medical terms. It's sort of akin to like a blast injury from like an explosion. There's a little bit of detail hidden here. We can see her mandible, so the jawbone, part of the spine, so the vertebra with the ribs coming off. And this here actually looks like the large bowel with the rectum. This should actually be a bit more floppy actually. What I like about this scene is you kind of often see the opposite. So a superhero comes in super fast and drags someone away, but that person would have huge trauma exposed to them. The G-force that would be on your body at that point would probably kill you, as all the tissue and fluid in your body would have to stay where it is because of the inertia. And as you move along, it would kind of rip through all the membranes that's keeping it in place. So all your blood would rip through your blood vessels, your brain would be mushed in your skull, your bones would kind of go through all the organs and probably fracture too. Pretty much everything we're seeing here. However, I'm imagining it wouldn't be quite as explosive as this. I mean, this literally looks like someone's had an explosion inside of them, which, come to think of it, we might see a bit later. In reality, if this happened, you'd be left with what I'd call more of a mutilated body. So imagine the limbs and other things flying off. You'd probably have the torso and clothes intact. But I think in a way that would actually be a bit more horrifying to see. So although more violent to explode, it makes it, I think, a little bit more comedic and less horrific. The other thing here for comedy effect is that Hughie is left here holding Robin's hand sort of cut off at the mid forearm. Really, to get this exact thing to happen, A-Train would have had to have chopped off the forearms first before exploding into Robin. So if we were crime scene investigators, maybe it's much less of an accident than we thought.
So tell us, how are you able to vanish?
No, I don't actually vanish. My skin turns into this carbon metamaterial that bends the light.
Translucent unveils in a Jimmy Fallon interview the way his power works. So his skin turns into a carbon metamaterial that bends light. You probably want a physicist to break down this thing, but you know, I'm going to give my best shot. And I think this does hold up to some extent. So the bending of light we call refraction, and if you could do it, as Translucent describes here, he would be invisible. We see this type of concept happen with something called a Luber's lens. So this is something that takes the light from either side and bends it forward. So the thing directly behind it appears to, I won't say be invisible, but to be hidden slightly. You know, that is assuming that the background is fairly consistent. But instead of just refracting light from the sides, we can see directly through Translucent, meaning this carbon metamaterial is probably operating a little bit more like a tiny fiber optic cables that take light all the way through. Where both of these concepts fall apart for me is that they'd have to be viewing from one particular angle. So Translucent would have to just be completely square onto you the whole time as he sort of shaped around the room. Or if there were multiple people in the room, he'd be more of a distorted image, which that actually makes more sense given his name.
Translucent doesn't even mean invisible. That means semi-transparent.
The other more medical issue is he says his skin is what causes it, and this leads to the comedy line that he has to be completely naked when using his power.
All right, but just to be clear, you have to be completely naked, right?
But clearly his nails and hair must also be made of the material. Maybe that's me literally splitting hairs. Or maybe he actually doesn't know how his power works. This is just the best explanation with the kind of experiments they've done. But coming into this video, I thought what actual things would be limiting this ability. And I think translucent, when he's invisible, would actually be blind, as you need light coming into the lens of your eye, so to concentrate it on the photosensitive retina at the back of the eye. And clearly this wouldn't be happening because it's being shaped around the body. So assuming his eyes are built like ours, when he went invisible, in order to be able to see, he'd still have to have his corneas, lens and retinas visible. So it'd be this kind of weird thing floating around. Anyway, I am way too overanalyzing that. We learn how the deep breathes underwater via abdominal gills. They, to me, kind of look like F-holes in a cello. As humans, we all have a little bit of a superpower that kicks in underwater called the mammalian dive reflex, where your heart rate slows down, blood gets distributed away from your limbs to your heart and brain so you can survive longer underwater. But as a medical doctor, I don't know a hell of a lot about fish respiration, so I did a drop of research. That's right, I gave it a Google and found this answer on Quora. Gills for a 150-pound human need to be at least as big for a 150-pound shark. Makes sense, right? Kind of like for like in terms of weight, and in this regard, the deep's gills look proportionally pretty accurate. Vlad goes on to say probably at least 3 to 5 times larger, as sharks are cold-blooded, so their metabolism is close to zero when they're relatively inactive, while humans keep their body temperature up and a bunch of other stuff all the time. Makes sense. So it takes a lot of energy for our body to maintain this kind of status quo, such as body temperature, so all our cells can function optimally. But what I think Vlad is forgetting is that there's around 20 times less oxygen dissolved in water than there is in air. So effectively the surface area of these gills would have to be around 20 times what our lungs are. But because these are superheroes, maybe the deep sea mutation also allows him to operate at a lower body temperature, or maybe there are kind of other efficiencies in his metabolism, such as an increased kind of mammalian dive reflex, so he can sort of survive longer underwater and need less oxygen. Overall though, I think these gills are very much on the small side. Sorry, mate. Translucent blows up from a bomb that's been inserted into his rectum. Pretty darn realistic. First of all, suppository explosives. This works for me. We give loads of medications rectally. You'd be surprised how much you could put up there. Does that make sense? And it's the rite of passage for any junior doctor to remove things from the back passage. Your mind probably automatically goes to people doing it kind of in a sexy way and getting a bit stuck, but I've seen prisoners come in who just fancy a day trip to the hospital, and people with mental health issues that put things up there as a kind of self-harm. But either way, I've never seen a superhero with a bomb up there. Although you get all types of things. The anal canal is surprisingly stretchy. The most similar to this scene that I've heard of is someone with a fire extinguisher up their back passage, which kind of sounds funny, but if that was to discharge, it would, you know, not be as dramatic as this, but certainly would perforate your bowel, meaning the bowel contents would go everywhere inside the abdominal cavity, you know, which can be fatal. I've also heard of a Buzz Lightyear doll working its way up there. I mean, you'd worry about the wings opening up. I actually can't fault this scene. Hopefully you can see this on camera, but the eye socket is made up of actually 7 facial bones fused together in this kind of pyramid shape, so with the point going into the skull, and it's very thin bone at the back here, and even has holes in for the optic nerve and the blood vessels to the eye. And we've seen the effect of Homelander's laser before, burning through metal, so it would easily go through this eyeball and penetrate the bone at the back here too. Eyes are often called the window to the soul, and that's very true. You know, if you were to look into the back of the eyes in the retina, you're actually seeing part of the optic nerve, and that is actually an extension of the brain. So if we look at this MRI of the brain here, we can see the eyeballs. The black bit there is the actual lens of the eye, and then the brain behind it. So given the angle that we see the laser come through here, the eyeball, it would then go through the optic nerve and the muscles here that move the eye, then the bony eye socket as we talked about, and then it's going to hit the left and right temporal lobes of the brain first. So as soon as this happens, you probably get loss of consciousness and maybe even a seizure too. If we just got isolated temporal lobe damage, we'd get memory problems, issues with speech and language. We often see this in certain types of strokes. However, if this laser goes a few centimeters deeper on this trajectory, we would hit the brainstem, and this would be instant death, as the brainstem regulates loads of our core functions, such as our breathing, our heart rate, our blood vessels, our consciousness, as well as being a relay for many other parts of the brain to the body. Damage to the brainstem can also lead to the super rare but kind of sort of very well-known condition called locked-in syndrome. Then we see the close-up of the damage, and I mean, it looks like most of the brain has been completely destroyed, which totally fits. You know, the brain is an extremely delicate structure. So once you've got this kind of superheated laser inside of there, it's pretty much just going to vaporize it. Compound V. Now, a few of you asked about this. It's a bit of a wonder drug. No wonder it costs 90 billion for one dose. What do we know about it? Well, first, it has two very different mechanisms of action. So first we learn it acts like a hormone, giving a boost to powers, and later we learn it's the actual cause of the superhero's powers. The concept of a drug having different effects, whether given to a developing fetus or to an adult, makes sense. So in our very early development in the uterus, our cells are multiplying, differentiating, meaning they're turning from a stem cell type cell to a specific type of cell. And this is a one-way process and only happens in these early stages of life. Then these cells undergo sophisticated organization to form our tissues, the structure of which is in place our whole life. Therefore, anything that impacts on this cell division or tissue organization will cause lifelong disability or even make the fetus incompatible with life. And these drugs are very often safe to use in adults. We call these drugs teratogens. Most famously something like thalidomide, a drug used for morning sickness in the 1950s that was found to, among other things, cause deformities in the limbs. In many ways, Compound V could be considered a teratogen because I'm guessing not all the babies survive its effects, but it also has these huge potential benefits in the form of creating soups. So there must be kind of more going on. And so to achieve these type of changes, you'd really be needing to modify the DNA. Therefore, I think it must have some kind of gene therapy element. Clearly, genes that give you gills don't exist. But even if we did know the genes we want to change, the other challenge is actually finding ways to insert these genes, so insert this genetic material into cells. To do this, we need some kind of vector. Traditionally, the vectors we'd use, you've probably heard a lot about them recently, are viruses because they inject genetic materials. They're very good at getting into cells. But more recently, we've actually developed non-virus vectors, so drugs that express receptors on their surface that get taken up by specific cells and then deliver the genetic material, which I think Compound V is probably in that camp. What doesn't quite make sense is how Compound V manages to have different effects on different people, because in theory, if it's inserting the same genetic material into each person, it will create the same kind of superpower. So that's a bit of a plot hole. Anyway, so leaving aside its ability to create superhumans, we also know it has this hormonal element. By that I mean it gives soups a short-term boost, making them stronger, more durable, increased healing, that type of thing. Physiologically, we have these things that act very quick and get us ready for action, something like adrenaline, so it gets your kind of muscles ready for that fight or flight reflex. And we also see some psychological and euphoric type effects, which probably add to its addictive properties that A-Train demonstrates.
Tell me, what's better, the rush or knowing that as long as you take it, you'll be the fastest?
I also read online that Compound V has side effects of paranoia, bone density problems, and increased risk of heart attacks. Well, One drug that does all those things is testosterone, a type of anabolic steroid, the drug you most often hear associated with people abusing to try and get ripped, although this takes a long time to work, usually weeks to months. So I think in summary, the hormonal part of compound V is probably supposed to be a kind of cross between adrenaline and testosterone.
Easy with that. You get some air in there, you could kill a kid.
Also, on this scene, bit of a movie mistake here. So although an air embolus in the blood can be fatal, they're using a vacutainer, so a collection tube with a vacuum, so wouldn't introduce air into the system. And because A-Train is doping way too much on the compound V, he goes into a cardiac arrest.
I think he's having a heart attack.
Hughie diagnosed a heart attack here, which is very rare in young people. You'd normally worry more about a heart arrhythmia, so an irregular heartbeat, but this would also be a medical emergency. However, on a background of compound V abuse and I think cocaine use, a heart attack would definitely enter the picture. So what could be happening to A-Train here? Well, let's assume compound V works a little like cocaine in that regard. A heart attack called a myocardial infarction is where you get death of heart muscle due to lack of blood supply. Cocaine is a quadruple whammy for the heart. It makes the heart work harder, it constricts the blood vessels to the heart, it makes platelets more likely to stick together, so more likely to get a thrombus in the blood vessels of the heart, and also the anesthetic effects of cocaine can also put the heart directly into a funny rhythm. Any combination of these could put A-Train into a cardiac arrest rhythm, which is where effectively there's no blood being pumped out of the heart.
1, 2, 3. Call an ambulance.
Now this is not perfect, but it's better than most. First of all, checking for signs of life, then calling an ambulance, and then pretty much straight into the CPR. Now you might think there was a bit of a delay there before he started CPR, but I've seen people in medical simulations take longer to identify and start CPR than Hughie here. So overall, that was pretty good. Ideally though, we should be checking for a response first, so the shake and shout. Then we'd want to check the breathing as well as the pulse if we can, just in case the patient has simply fainted, because we don't want to be doing chest compressions on someone if they're still breathing and their heart's still beating. One bad thing here is they stop chest compressions. So once you've started chest compressions, do not stop. As soon as you stop chest compressions, the blood starts pooling again, and it takes a few of them just to get the blood even starting to move. Also, there's a very real possibility here that A-Train is in a shockable rhythm, so a type of cardiac arrest that will respond to a defibrillator. And given Starlight's power, I wonder if she should try to give him a little bit of a shock. That's what I'd do, although you'd probably get a lot of trouble if it went wrong. So there you have it, my thoughts on some of the medical science that you wanted to know from season 1 of The Boys. If there was anything that you also wanted me to talk about, or maybe some stuff from season 2, then leave a comment down below. And if enough people want to know enough things, I'm more than happy to have another look at this show, because as I say, a fantastic show, and I still haven't seen season 2 yet, so very much looking forward to that. And lastly, thank you to you guys for watching, for all the support on the channel, both before the pandemic, during the pandemic, and as we're learning this new normal together. I hope you're all well, and I'll see you soon.